Okay, so yesterday we started talking about writing things as a matrix by removing the variables, but it had to be, remember, x, y, equal sign was an augmented matrix. Okay. Oh, I'm going to do this one by hand. This is a watch me moment, okay? And see if you remember any of this from Algebra 2. My understanding is you did these in Algebra 2, but I could be wrong. So when you have three variables, three equations and three variables, what you do is you get rid of one of the variables using different equations. So please pay attention to this so that how this magic matrix business works makes a little bit of sense to you. Because most years I'd make us practice it by hand a little bit. But so what I'm going to do is add these two together. Why would I pick those two? Yep, see the y's will drop out. Everybody see that? Okay, so if I add those, I get 5x, the y's drop out. Back here I get negative 1z equals negative 7. Does everybody see what I did? I added those two. Okay, then I'm going to move over here and I'm going to take this equation that I haven't used yet. And I need to make, this is a 2, sorry. I need to make the same variable drop out using a different equation. So I'm going to take this second equation and multiply by 2. Is everybody watching? So this second equation would become 4x plus 2y minus 6z equals negative 14. I multiplied that whole guy by 2. Got it? And I did that, so now I can add these. And what do I get? 5x, these drop out. I get a negative 5z equals negative 15. Everybody good? Now I have this equation and this equation that both only have what? X and z. It also happens to be really nice because they both have 5 x's. So if I multiply this guy by a negative 1 and write him down here, he'll be negative 5x plus 5z equals 7. Then if I add those two, what did I do wrong? Oh, I was multiplying by negative 1, so this should be negative 5x plus 1z, right? Like everything can't drop out, that's not a good moment. Negative 1 here, this would be a plus 1z and a plus 7. Okay, fixed. Add these together now, and I get negative 4z equals negative 8, which means z is 2. Where could I put that back in? I can put it anywhere, but I want to put it somewhere that doesn't have 3 variables. So, I don't know, if I picked right there, it would then say negative 5x plus 1 times 2 would just be 2. Everybody with me? Oh, look what happens here. Definitely don't need to be writing this down, but what do I have left to find, guys? Oh, y. Okay. So I'm going to maybe pick, I don't know, I can pick any of them. Let me see. How about if I pick, what if I not use blue? This guy, because he has a plain old y in the middle. Does that make sense? So I would have 2 times x plus y minus 3 times z, which is a 2 now, equals negative 7. All right, that would give me negative 2 plus y minus 6 equals negative 7. So I need to add 8 to this side to get rid of those. So then I would have y equals 1. So I had x equals negative 1, y equals 1, and z equals 2. Did you want to do about 6 of those by hand? Because that used to be what we had to do. Okay, not so fun. Now, you can solve a system of linear equations by using matrices, and I'm going to show you how to do that. Solving a system by transforming it into an equivalent system is called Gauss-Jordan Gauss-Jordan, I've seen it called, elimination. First, we create the augmented matrix. This is what we practiced yesterday. This means removing the variables. Then we use what are called elementary row operations to transform the matrix so that it is in row echelon form. And then we write the corresponding system of equations using substitution to solve the system. Okay, so I'm going to show you how this works. Everybody in here except Kaylee saw what we did yesterday. This is what we did yesterday, Kaylee. All we did was took out the x, y, and z. So this first equation became 1, -2, 1, -1. See that line right there? And then the second equation became 2, 1, -3, -7, this line in the middle right here. And then the third equation became 3, -1, 2, 0, 3, -1, 2, 0, because all we did was took out the x, y, and z. These were all the x's, these were all the y's, these were all the z's, and this is what it was equal to over here. Everybody remember doing that yesterday? We good? Okay. Now, I'm going to show you how you used to have to do those by hand. Let me go through the operations. You are allowed to interchange any two rows. Think about that. Can I move the first equation to the second spot and the second equation up to the first spot? That's not doing anything, right? You're allowed to multiply a row through by any number. Did I do that when I did it by hand a minute ago? Multiplied through by a 2 and then added it to something else? Okay, you're also allowed to add a multiple of one row to another row. So I did all those things, but I had variables to work with. All right, I'm going to show you how this works by hand. -2, 1, -1, 2, 1, -3, -7, 3, -1, 2, 0. Okay, so back in the day, Hofbauer would have said, I'm going to multiply the top one by -2 and add it to the second one. So the top one is going to stay the same. I'd really like you guys to try to help me do this so I don't make an arithmetic mistake. All right, so we're -2 times the top one, added it to the second one. So -2 times 1 to 2 would be 0. -2 times -2 is 4. Added down to that one is 5. -2 times 1 would be -2. Added to -3, -5. -2 times -1 is +2. Added to -7, -5. Now before I write the third row down, I'm going to multiply the top one by a 3 and add it to the third row because I want this to be a 0 as well. Oh, -3 would work better than Hofbauer. -3 times 1 added to 3 would be 0. -3 times -2 would be 6. Added down to that -1 would be 5. -3 times 1 is -3. Added to 2 is -1. -3 times -1 is 4. Added to 0 is 4. Did I mess anything up? Wait a minute. -3 times -1 on a good day is just 3. Did I mess anything else up? Okay. Now, the next thing I'm going to do, I think I'm going to leave. You know what? I'm going to divide or multiply this whole row by a 1/5. Okay? Do I want to do that first? These are the kinds of decisions you're not going to have to make because the calculator is going to do it all for you. You were born in a good era. How's that? Okay, so what I'm going to do is leave the top row. I'm going to take the next row and I'm going to redo the bottom row by doing -1 times this row and add it down to the bottom one. So that would be -5 added there would make that a 0. -1 times 0 added to 0 is 0. -5 times this added to this would be 0. -5 times this would be 5. Added here would be 4. -1 times -5 would be 5. Added there would be 8. And then what I'm going to do is divide this row. Before I write this row down, I'm just going to divide it all by 5. or multiply by 1/5. So this one is going to become 0, 1, negative 1, negative 1. All right. Now, I'm almost done, guys. I'm going to do 2 times this middle row and add it up here. Well, 2 times 0 added to 1 stays 1, right? 2 times 1 added to negative 2, 0. 2 times negative 1 would be negative 2. Added up here would become negative 1. 2 times negative 1 would be negative 2. Added to negative 1 would be negative 3. Middle one is going to stay the same. The bottom one I'm going to divide by 4, okay? Or multiply by 1/4. So I'll get 0, 0, 1, and 2. All right, I'm almost done. Last step. I'm going to take this bottom one and add it up to the top one. So 0 plus 1 is 1, 0 plus 0 is 0, 1 plus negative 1 is 0, 2 plus negative 3 is negative 1. Then I'm going to take this bottom one and add it up to this guy. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus negative 1 is 0, 2 plus negative 1 is 1. And the bottom one is going to stay the same. Okay, can you go back to how we started this? What were these, this whole first row? X, Y, Z, and equals to? Remember that? So what does this equation now say? 1x plus 0y plus 0z equals, so it says x equals negative 1. What does the second equation say? 0x plus 1y plus 0z equals 1. Third row, 0x plus 0y plus 1z equals 2. Okay. Negative 1, 1, 2. Negative 1, 1, 2. Okay. So I did it once with the variables in, once without. You ready to learn the real magic? Okay. This form right here, where all of this piece over here is 1s and 0s, and the 1s are on this diagonal, okay? That's called, when we get it in this form, it's called reduced row echelon form. You have this slide, I think. Is that right? Okay, hang on, let me scooch this over a little if I can. So when you have 1, 1, 1 on the diagonal, that will tell you what those variables are. We've been using X, Y, and Z. Okay, this is called reduced row echelon form, and we got it by using what's called Gauss-Jordan elimination, but you're not going to have to do that. Okay, so in your notes, you need to write that our calculator form is going to be called RREF is the command we're going to be looking for. And it's going to stand for reduced row echelon form. All right, now we're going to go to the calculator and learn how to put a matrix in first. So on your calculator, let me see. On your calculator, you're going to go to matrix, so you're going to go second, and then right below math, it says matrix, so we're going to hit that button right down there. Everybody good? You should have this little square A, B, C, D, but you might not have numbers next to yours. We want to edit what is in one of the matrices. So I'm going to go over to edit, 2 to the right, and you can pick any of these. I'm just going to put it in matrix A, so I'm just going to hit enter. You can put it in whatever your favorite letter is if you want. Now, you might not have anything in here right now, which is fine. What size was our first matrix? This is why you had to know the size or the dimensions yesterday, because you have to be able to put in the calculator. It was a 3 by 4. Okay, so you're going to type 3 and then arrow to the right. Do you need the times? You just arrow to the right. Yeah, should be 3 by 4. I don't know why it has that little space in there, but it worked, right? And then if you hit enter, I think, did you get a bunch of 1s and 0s or blanks at least so you could fill this in? Okay, mine has junk in it already, but I need you to read me our original one, or I can go back and look. It was this guy, this red one right here, right? So we're going to enter that in. Every time you put in an entry, you hit enter to go over. So we have 1, enter, okay, 1, enter. If it messes up, you can go back to the box and type over the top. -2, oh, darn it. This is not going to work for me. -2, enter. Then what is it? Can someone read it nice and loud? 1, -2. Thank you. Next one. 2, 0. Okay, I cannot stress enough that you want to proofread this, because if you entered anything wrong, the littlest sign will make a huge difference when we do this. So hopefully mine is right. You guys were all watching. 1, -2, 1, -1, 2, 1, -3, -7, 3, -1, 2, 0. We good? All right, here comes the magic. You need to quit, so go second mode so that you're back on the home screen. Everybody good? Okay. Now you're going to go back to matrix, second matrix, but we're going to do some magic or math, because math is magic, right? We're going to go over to the right one to this math button. Now, it's really kind of hidden here because we didn't used to let students use it, but we don't have time to do them by hand this year. So we're going to go down all the way down to RREF. Make sure you pick the RREF. The first one will only reduce it partially. We want it completely reduced. Reduced row echelon form. You're going to hit enter. Now on the home screen, it should look like this, but you have to put the name of the matrix in. So go back to math. Matrix, second, this guy. And then you're just going to put the name. So I put mine in A, so I'm just going to hit 1 or type enter. This is what it should say on your screen. Reduced row echelon form of A. How we doing? This is like the magic and the easiest thing you're going to learn all year. Adrielle, are you typing these? You good? Okay. So now we're going to hit enter. Did anybody not get it? Because if you put in something wrong, you'll get crazy answers. We good? So what does this tell us again? X equals -1, Y equals 1, Z equals 2. Yes? Okay. Magic. All right. So we're going to do one more together here. What do we have to remember from yesterday, guys? Kaylee wasn't here. Can anybody tell her what we have to be careful of on this one? This last line down here? Yeah, I guess we always have to have the same lineup, right? It has to go X, Y, Z equals. So this one, we're going to write the augmented matrix. 1, -2, that's a 2, not a Z. 1Z and 15. What's the next line going to say, guys? Now the last line, you gotta be real careful. It's gonna be -1 for the X column, +1 for the Y column, but there's no Z, so we gotta put a 0 in there, and then -9. Everybody awake and doing this? Antoine, you good? This is the easiest thing we're gonna learn all year. So we took this X, Y, Z's out and wrote the matrix. Now we're gonna go to our calculator, and where are we gonna change our matrix to this? Anybody tell me how to get there? Second, then the X to the -1 over to edit. Now you can choose to put it in B this time if you want. I might, just because then later I won't have to retype them when I'm teaching this in another class. Or you can put it right on top of the other one. It is a 3x4. Okay. One, negative. Can anybody read it? Dang it. I should have it on paper in front of me. Proofread yourself. -9? Yeah. Okay, if I did it right, now I'm going to quit. Where do we go? Back to matrix, but we go over to math. Yeah, it's B or RREF down here. Now, back to matrix to put the name in. And I put mine in 2, matrix B, so you guys could, if you just put it over the top. But did everybody get 4, -5, 1? I don't know if some of you are really typing this, so I'm gonna... Where are you at? You getting this one on here, dude? All right. Everybody good? Okay, I should edit that middle of that video, but anyway, okay. Now, I want to talk about when a matrix has no solution or infinitely many solutions, though I didn't put it on the test, okay? On the back, I think you have this. Do you have this at the top? Okay, what would this, when we put it back into an equation, if these were X, Y, Z, and equal to, this first equation would say X equals, then Y equals 4, Z equals -20, so we would have had 19, 4, and -20. That one seems okay. The second one, be careful, what does the second one say? 1x, this is X, Y, Z, minus a Z equals 0. What does the second line say? And the third line says nothing over here equals 1. Do you think that's many solutions or no solution? Okay, this is a false statement. Remember what I said early on when we were starting systems? If you get a false statement anywhere along the line, it's no solution. All right, help me with this last one. If this is X, Y, and Z and what it's equal to, this would be X minus 6Z equals 4. And the second one would be Y plus 2Z equals -3. But the last one says 0 equals 0. None of those are false statements, so this line means many solutions. Now, it used to be part of the final that you had to write all the solutions in terms of Z. So you would say Z could be any number, If you solve this for y, it would be -3 minus 2z. And if you solve this for x, it would be 4 plus 6z. I am not going to talk any more about that this year because I didn't put it on the final, okay? And it is a confusing idea to solve these. This means z could be any number, but then you'd have to do this and this to find the corresponding x and y. All right, I didn't put this idea on the final at all, but you have to be careful that you still always have this, right? For it to have a solution, okay? So let's practice 2 more times, or maybe, do you think you got it? Let's just do number 2 if you think you got it, because this one, what do we have to remember there? Yeah, we got some zeros. So what's the top line? We're taking out the x, y, z, and the equals. So we got -4, -1, -1, and -11. The second one, be real careful, there's a 1x, but there's 0 y's, a -1 z, and a 2. Everybody okay? This should be the easiest thing all year. I keep telling you, don't make little mistakes. And the bottom line has what? Okay. And then we're going to put this in our calculator and we're going to do RREF to it. What size is it again? This one is a 3 by 4. Oh, I forgot to go over to edit. You got to be in edit. Three by 4. All right, -4, -1, -1, 11. Darn it. Proofread before you try to. Was it -11 for the first one? Okay, anybody want to read me the next one? This one's 0 something? Okay. So then we quit, so that we're on the home screen. Then you go back to Matrix, over to Math, find RREF, which is choice B, and then you have to put the name of wherever you stored it. I stored mine in C, but if you keep putting them over the top of each other in A, I'll give you a hint. Look, if I went back in and changed C, the matrix, I could just hit enter and it would repeat this. So if you keep putting them on top of each other in A, you can just hit enter and you won't have to redo it. It'll recalculate it. But anyway, that's just a shortcut. This means x equals 3, y equals -2, and z equals 1. I have lost what we were doing. So my solution, and you could write that down if you wanted, but can anybody tell me what it came out again? I heard number. What? 2? No? Three, -2, 1. You're good, Jada. Okay. You maybe stored it in a different one. All right. We're going to do a nasty word problem just to show you how helpful this idea is. And I also want you to know that you can do this on a smaller word problem. If I had a system, maybe I'll just talk about that real quick before I do this question. If I had a system that we had written from yesterday, like 7 shrubs plus 11 ornamental grass equals $232, and a shrub and 7 grass equals $194. Could you solve that system with a matrix? It would just say 7, 11, 232, 1, 7, 194. What size would you be putting in though? 2 by 3. And then you would still use RREF, and it would come out 1, 0, and the price of one of those, and 0, 1, and the price of one of those. Now this is not going to work. Don't try this one because I made this up, okay? But does everybody see that it could work with a 2 by 3? So now if you have not done your delta math, you can go back and cheat and use RREF on everything. And you can do that on the quiz, but there are some that it's going to say show algebra, okay? Or show by elimination, show by substitution. But you could always check it on the calculator. All right, let's do this number 3, manufacturing. Company manufactures 3 things, and we want to determine the number of each that they build. So I'm going to use X equals number of, what do you want me to use? Tables. Y equals number of chairs. And Z equals number of stools. All right, do we know, I'll let you read the question to yourself here. Last week it built total of 275 items. Number of chairs built was 4 times the number of tables and stools. The total value is $42,125. If they sell chairs for $150, tables for $200, and stools for $75. Okay. How many total did we sell? If we every table we made plus the number of chairs plus the number of stools. Oh my goodness, I can't talk. Totaled how many? Didn't it say 275 items up here? Okay. Then there's one that's dollars. I think I'll do that one next. It doesn't matter what order you do them in. Remember, you can switch your lines in your matrix anytime. But the chairs are 150. Oh, tables are supposed to come first. What are tables? Oh, $200 for tables. And then chairs are 150 and stools are, and that made us $42,125. I think I did this wrong earlier today when I did, because I don't think I had those in the right spot. All right, now the last equation is the one that gets everybody here, but it says chairs was 4 times the total number of tables and stools. So it really is just a translation question. Chairs equals 4 times the total of the tables and stools, which would be X plus Z. Okay, but we're going to need to rearrange that to put that in our matrix. What is that going to look like? Anybody know how we're going to make that fit so that the X and the Y and the Z are all on the left? Okay, we could move the X's or the Y's either direction, guys, doesn't matter. Okay, what Jada says is let's subtract the Y over to this side, and then let's put the equal sign over here. Okay, it doesn't matter. You can change all the signs on them, you get the same answer, I promise. Okay, so now let's put it in. You can write the matrix if you want, or just type it in, but it's 111,275. And it doesn't matter if you put them in a different order as far as which one you put second, but I have a 200, 150, 75, and 42, 125 for -1, 4, 0. 275. And then 200. And then 150. And then 75. 42, 125. How am I doing? And then did we do 4, -1? 4, oh, can't use that stupid. Okay, this needs to be a -1, okay. 4 and 0? Is that what we had? Okay. So if I have it in right, I put mine in D, so I got to do this all over again. $42, 20, 15, anybody? Anybody not getting that? If you get crazy decimals, it's probably because you put in something wrong in your matrix. 42, 20, 15. So what do we write as our sentence? They sold. Was it 40 or 400? 40 tables. Was it 2 something? Oh, 220 chairs. 15 stools. Okay. Did those just become so much easier? Okay. I think I'm going to stop there for today. I was going to do one of these, but we have more time tomorrow. I can do one as a review. So you have your very last Delta Math of 2021 assigned tonight. Unless I decide to make some up. If anybody wants like an optional review for the final on Delta Math, I could certainly put one together. But otherwise, I have lots of review worksheets for you. And the answer keys will be in Google Classroom when I get those posted, okay? Any questions?